But could there be something even more mysterious awaiting us? Buckle up as we journey from the floating corridors of the ISS to the distant horizons of the universe. Part 1. The Beginning. A Light from Earth's Orbit. Welcome to Extraterrestrial Mystery, where we shine a light on the deepest secrets of the universe. Picture this. A fortress floating among the stars, 400 kilometers above Earth, where the brightest minds of humanity work tirelessly to unravel the mysteries of the cosmos. This is the International Space Station, or ISS, a scientific masterpiece, a beacon guiding us toward our dream of conquering other planets. Today, we'll step into the world of astronauts, brave pioneers facing the void of space to answer one monumental question. Can humanity survive and thrive beyond Earth? On the ISS, astronauts from NASA, JAXA, Roscosmos, and the Canadian Space Agency are conducting experiments that will leave you in awe. They monitor human health in zero gravity, study how to grow food for future colonies, and keep this colossal space machine running smoothly. But what lies behind these experiments? Are they the key to reaching the Moon, Mars, or even farther? Or are they revealing greater mysteries about life in the universe? Join us as we explore a day on the ISS, where astronauts like Nicole Ayers, Takuya Onishi, Anne McLean, Johnny Kim, Sergei Rizikov, Alexei Zubritsky, and Kirill Peskov work relentlessly. From collecting blood samples to study the immune system, to monitoring hearts in space, to planting seeds for the future, each experiment is a ray of light in our quest to conquer the cosmos. Part 2. The Immune System in Space. Secrets of the Human Body. Envision this. You're floating in a world without gravity, where your body faces rules entirely alien to Earth. Your blood flows in strange ways, your muscles weaken, and your immune system, the hero shielding you from illness, begins to falter under the power of space. This is the daily reality for astronauts on the ISS. But what's happening inside their bodies? And why is it a mystery that captivates us? Part 2. The Immune System in Space. Secrets of the Human Body. Envision this. You're floating in a world without gravity, where your body faces rules entirely alien to Earth. Your blood flows in strange ways, your muscles weaken, and your immune system, the hero shielding you from illness, begins to falter under the power of space. This is the daily reality for astronauts on the ISS. But what's happening inside their bodies? And why is it a mystery that captivates us? Microgravity, cosmic radiation, and prolonged isolation can weaken cellular immune function, making astronauts more vulnerable to illness. But why does this matter to us? Picture yourself on a spaceship bound for Mars, living for years in the depths of space. A weakened immune system could turn a simple cold into a catastrophe. These experiments not only help doctors monitor the health of the ISS crew, but also light the way for long-term missions. Are NASA and JAXA preparing us for a future where humans can thrive among the stars? But pause for a moment. If our immune system changes in space, what does that suggest about life beyond Earth? Do other beings in the universe have immune systems like ours? Or have they evolved in ways we can't yet fathom? These blood samples might be the first spark illuminating answers to these questions. When you think of those vials floating in space, do you feel a thrill, wondering if we're inching closer to the secret of life itself? Part 3. The Heart in Space. The Beat of the Cosmos. Visualize this. You're in a place where your heart must function in an entirely new way. In space, with no gravity pulling blood downward, an astronaut's heart faces unprecedented challenges. But what happens when you live for months in this environment? Can the human heart withstand the trials of the cosmos? But why does this experiment demand our attention? But let's think bigger. If we want to settle on the Moon or Mars, how will the human heart adapt to these alien environments? In microgravity, blood doesn't flow as it does on Earth. It pools in the head and chest, putting pressure on the heart and increasing the risk of arterial stiffening. These changes could lead to serious health issues during long missions. Anne's experiment helps scientists better understand cardiovascular risks and develop ways to protect astronauts, from specialized exercise routines to advanced medications. Part 4. Bio, Monitor Technology, Tracking the Light of Life. Picture this. You're wearing a headband and vest that can record every heartbeat, breath, and movement, all while you float among the stars. This isn't science fiction. It's reality on the ISS, thanks to the biomonitor technology from the Canadian Space Agency. But what secrets does this device hold? And why is it a radiant light in our cosmic journey? Astronaut Nicole Ayers completed a session with the biomonitor, an advanced sensor system designed to comfortably track vital signs during her daily activities. For 24 hours, it recorded everything, from her heart rate during sleep to her body's responses during exercise in the Destiny module. She then downloaded the data for doctors on Earth to analyze. But what makes this technology so special, especially for those of us dreaming of cosmic wonders? The biomonitor doesn't just track astronaut health. It opens the door to the future of medicine. Envision this: a wearable device that can detect health issues early, not only in space but also on Earth, where communities could benefit from remote health care. Hospitals could use this technology to monitor patients, or athletes could enhance their performance. But in space, its importance is even greater. When you're millions of kilometers from Earth, a device like the biomonitor could be the light that saves your life. But let's dive deeper. If we develop technology to monitor humans in space, could it also detect other forms of life? Could a similar device pick up biological signals from extraterrestrial beings? When Nicole Ayers removes the biomonitor headband, she's not just finishing an experiment, she's igniting a path toward greater cosmic mysteries. Are you curious to see where that light leads us? Part 5. Physical Fitness in Space. The Strength to Conquer the Cosmos. Envision this. You're in a place where your body must fight to survive. Without gravity, your muscles and bones weaken, as if the universe itself is testing your strength. To overcome this, ISS astronauts train like true cosmic warriors. But how do they maintain their strength? And what does this reveal about our future in the cosmos? Roscosmos flight engineer Alexei Zubritsky steps onto a treadmill in the Zvezda module, wired with electrodes to measure cardiovascular fitness. As he runs, he's not just staying fit, he's providing critical data on how the body responds to microgravity. These workouts aren't just about exercise, they're about survival. Without gravity, muscles can atrophy, and bones lose density, making astronauts prone to injury upon returning to Earth. But the ISS isn't just equipped with a treadmill. It boasts advanced exercise devices, like resistance machines and space bikes, designed to mimic gravity and keep astronauts healthy. Every day, they dedicate hours to training, fighting their body's decline. But what sparks our curiosity is this. Will these workouts suffice for humans living for years on Mars, where gravity is only 38% of Earth's? And if we settle there, how will our bodies evolve? Visualize a future where humans no longer need these devices because our bodies have fully adapted to space. Could we become a new species, shaped by the cosmos? As Alexei runs on the treadmill, he's not just staying healthy, he's lighting the way to answer the question, can humans truly call space home? Are you ready to keep exploring? Part 6. Breathing in Space, the Secret of Life. Picture this. Breathing. The simplest act we do every day. But in space, even breathing becomes a mystery to unravel. On the ISS, astronauts are studying how their lungs function in microgravity, and what they discover could change how we view life itself. Sergei Ryzhikov and Alexei Zubritsky from Roscosmos are part of a unique experiment, attaching acoustic sensors to their throats to record breathing sounds as they exhale forcefully. Why do this? In microgravity, bodily fluids shift toward the chest and head, potentially affecting lung function. This experiment helps scientists understand how breathing changes in space, paving the way for protections during long missions. But let's think deeper. Breathing isn't just about oxygen, it's the signature of life. If we find planets with alien atmospheres, how will humans adapt? Can our lungs learn to breathe in those environments? And if we encounter extraterrestrial beings, will their breathing resemble ours? The sounds recorded by Ryzhikov and Zubritsky aren't just data. They're beams of light guiding us to profound questions about life in the universe. When you think of those breathing sounds echoing in the silent expanse of the ISS, do you feel a shiver? Are these experiments bringing us closer to the secret of life beyond Earth? Let's keep exploring to find out. Part 7. Growing Plants in Space, Seeds of the Future. Visualize this. A garden floating among the stars, with no soil, no gravity, just green shoots reaching for artificial light. This isn't a fairy tale, it's reality on the ISS, where astronauts are studying how to grow food to sustain humanity in space. In JAXA's Kibo module, astronaut Takuya Onishi is dismantling hardware from a plant biology experiment, studying how plant cells divide in microgravity. The goal? To discover how to grow crops in space to provide fresh food for long missions. Picture this. If we want to settle on Mars, we'll need food, and shipping tons of supplies from Earth isn't practical. These space gardens could be the light leading us to a multiplanetary future. But growing plants in space is no easy feat. Microgravity disrupts root growth, and sunlight is absent. ISS scientists use systems like plant habitat and veggie to experiment, and every step forward is a triumph. As Takuya Onishi inspects tiny sprouts in the Kibo module, he's not just doing science, he's planting seeds for the future. But pause and reflect. If we can grow plants in space, what does that suggest about life beyond Earth? Are there planets with alien forests, nurtured by laws we don't yet understand? These experiments aren't just about food, they're beams of light illuminating the possibility of life in the cosmos. Are you curious to see where these sprouts will lead us? Part 8. Maintaining the ISS. Keeping the light of life alive. Envision this. You're living in a massive machine floating in space, where every component is a lifeline. A tiny error in the oxygen system, a leak in the plumbing, or a faulty hatch seal could spell disaster. On the ISS, maintenance isn't just a task, it's a mission to keep humanity shining in the cosmos. NASA flight engineer Johnny Kim spent his day working on a catalytic reactor in the Tranquility module, a vital device for air processing. Alongside Takuya Onishi, he inspects and cleans hatch seals on the Tranquility, Harmony, and Permanent Multipurpose modules, ensuring no air leaks. Meanwhile, Nicole Ayers cleans the microgravity science glove box, which houses experiments in biology and physics. Elsewhere, Sergei Ryzhikov maintains the oxygen generator in the Zvezda module, while Kirill Peskov checks the plumbing and electronics. These tasks may seem routine, but in space, they're critical. The ISS is an artificial ecosystem where everything, from the air you breathe to the water you drink, depends on complex systems. A small mistake could endanger the entire crew. But what sparks our curiosity is this: how will we maintain such machines for decades on the Moon or Mars? And if we encounter an alien civilization, will they have similar technologies to sustain life? As Johnny Kim and his colleagues work in the quiet of the ISS, they're not just keeping the station running, they're lighting the foundation for future space colonies. Can you feel the tension and wonder of these moments? Part 9. Communication in space. Connecting with the cosmos. Visualize this. You're in a place where isolation is inevitable. Far from Earth, astronauts must work together and with ground teams to keep everything functioning. But communication in space isn't just about talking. It's the light connecting humanity to the cosmos. Roscosmos flight engineer Kirill Peskov begins his day with a computer-based test, studying how international crews and global mission control teams communicate. This isn't just a technical issue. It's about forging bonds across cultures, languages, and mindsets in a harsh environment. He then moves on to maintain the plumbing and electronics, ensuring the ISS runs smoothly. But let's dive deeper. Communication is the foundation of every civilization. If we encounter an alien civilization, how will we talk to them? Could the lessons from the ISS, where astronauts from different nations collaborate, help us connect with beings from the stars? As Kirill completes his test, he's not just improving crew coordination, he's lighting the way for humanity to prepare for greater cosmic encounters. Picture a future where we don't just talk to each other, but to entities from distant planets. Is the ISS the first light guiding us toward communicating with the cosmos? The answer may lie in the data Kirill collects today. Part 10. Conclusion. A light leading to the stars. We've just journeyed through a day on the International Space Station, where astronauts are illuminating the mysteries of the cosmos. From studying the immune system with Nicole Ayers and Takuya Onishi, to monitoring Anne McClain's heart, from JAXA's space gardens to the maintenance tasks of Johnny Kim and Kirill Peskov, each experiment is a ray of light in humanity's grand journey. But what awaits us out there? The experiments on the ISS don't just teach us how to live in space. They light the path to missions on the Moon, Mars, and beyond. Technologies like the biomonitor could transform medicine on Earth, while space gardens could feed future colonies. But what truly sparks our curiosity is this. Are these experiments bringing us closer to discovering extraterrestrial life? Could the seeds, heartbeats, and breaths recorded on the ISS be the light guiding us to the truth about life in the universe? At Illuminate the Cosmos, we believe every step on the ISS is a light leading us to the stars. Join us as we continue to shine a light on the mysteries of the universe, from floating laboratories to uncharted planets. Don't forget to hit like, subscribe, and turn on notifications to never miss a journey. What do you think about the mysteries of the ISS? Share your thoughts in the comments. Together, we'll keep illuminating the path to new horizons.